Welcome. Welcome to Berlin. Hope you're having a great conference so far. Thank you very much for joining me for this session. We're going to talk a bit about artificial intelligence, in particular in the framework that we refer to as Analytic Ops, short for Analytic Operations. Imagine DevOps meets machine learning. And you're using this technology and this set of technologies to continuously improve business outcomes. Basically, I'll talk a little bit about the motivation for analytic ops, in particular how AI brings a lot of challenges that we need a framework for addressing. And then I'll walk you through a case study with one of our large banking customers, using this framework to help them achieve business outcomes, improvements in business outcomes. And then I'll just highlight some of the key features of analytic ops solutions that that we find to be really critical and that we've developed into our own AI accelerators. So the race is on. AI is happening across the world. It is maybe since 2012, and these improvements in deep learning have really caught the popular imagination, but also the imagination of executives across industries. There are lots of different use cases, and we have many customers who are using AI and who are consulting with us to develop AI solutions in their businesses. And it is a race. I mean, if you are an enterprise and you're not looking for ways that you can use AI to improve your existing machine learning models or to automate some of the processes that you have in place, then you will be outcompeted by those of your competitors who are using AI. And not only to find those insights and to automate, but to bring those into production. And that brings up the need for analytic ops. Now, this is a problem that's familiar to anybody who's actually done any kind of machine learning in the enterprise, is that how do you go from the insight that you can get using advanced analytics to actually capturing business value based on that insight, right? So, and it's not realized when your super smart PhD who's gathered all the data, extracted it from your data lake, from your variety of databases, and spent a long time bringing everything together and has built a beautiful model. You don't get business value there. You get the promise maybe of business value, but you've got to get it into production somehow. How is it going to be on an ongoing basis? You're going to have that affecting decisions or the processes that are ongoing within your business. The problem has been traditionally that the time to market from insight to production for complex large-scale organizations can be a year or more, and not infrequently you'll find that whatever value was there when the data scientist found it is no longer there when it's brought into production. It's just there's been too much time lag, too many things have changed, the market has changed, and there's no value capture. Gartner said that maybe only 15% of big data projects reach production, actually affecting business on an ongoing basis. Definitely been consistent with our customers as well. And even once you do get, let's say that you do take those machine learning models, you bring them into production, that unless you have a process and a framework in place for updating that model on an ongoing basis, making sure that it hasn't decayed, you got to replace it with something that actually is still that is working, then even that static data product is going to quickly lose value. So there are ways of answering that challenge, and we bring analytic ops as a way of overcoming the value challenge. We always begin with the end in mind. We want to prioritize production. Business value is what we're going for our customers, and we know that in order to capture business value, it has to be affecting ongoing business processes, and so it has to be integrated into production systems. All right. Now, production systems, oftentimes, and these are application, there could be a lot of different business applications. There could be a lot of software. There's an emphasis right on robustness, about repeatable processes. And that's much more of an operations setting, right? So we need to be able to bring analytics into operations. We also need to anticipate that there's going to be change on an ongoing basis, and that we have to be able to respond rapidly, systematically, and in a robust way to changes in the system. By incorporating a lot of DevOps practices into analytic ops and building some tooling around that, we've found that a lot of our customers are able to capture value and sustain the value capture through this analytic ops framework. And this is new. This is different, right? So analytics oftentimes emphasizes the more blue sky, the kind of flexibility. You've got lots of iteration. It's not the place where you care as much about high availability or about all the production type things that you might concern yourself with, security and governance and compliance. And so that's been an opportunity. Like, so how do we bring some of the production type characteristics and things that we need for our production systems into the analytics workflow that we're enabling? If you can do that, if you can marry those two together, then you do get lots of value. You get more business insights into production quickly in a way that's robust and it's compliant, has all the benefits of a robust operations framework. Reduced time to market, improved quality of product, reduced maintenance overhead. All of these things are important for some of our customers, especially in healthcare and in financial services. Regulatory compliance is essential. And all a great number of different users benefit from having a framework that guarantees more agile updates to data products and maintains their robustness. Not only business end users who say, yeah, my product would be so much better if you could incorporate your predictions or your forecasts or your fraud detection. They can get those. They can go from that request to an integrated machine learning or deep learning insight on a much more rapid basis. And then, of course, data system owners, DBAs, they are granted more governance and clearer processes for how do those models from that data science team make their way into production, and can they have faith that that's not going to break the system, or that if the new model is worse than the old one, that they have a quick way of rolling back to a system that did work. The same kinds of guarantees that they would have if they're using a kind of more DevOps type approach to their application development. Data science teams have the promise of optimization and automation, that they can actually, they don't have to do everything themselves, maybe especially on kind of the ETL pipelines in the front end, but as well as the model deployment process. And so there's a lot of teams that benefit from an analytic ops framework. Let me tell you a little bit more about what this might look like in a financial services, kind of a retail banking setting. We've done a number of projects around fraud detection, and there's lots and lots of different types of fraud. Unfortunately, I think probably most of us in here have suffered from some type of fraud, or at least if we've been attacked by fraudsters. The problems with detecting that fraud and responding to that fraud are many. So some of them, they begin with that it's very difficult to detect fraud, right? So to actually have a true positive, so have a model that says, okay, this transaction or this interaction is has one of the people is involved in this, or this is a fraudulent transaction. So there's a low detection rate for true positives in general. And there's tons and tons of false positives because it's costly when you miss fraud. So you want to have your machine learning models or whatever your rules are that you're using to try to detect fraud, that they can also throw off a lot of false positives. So say, yeah, I think this is fraud. You should look into it. And you have these, and banks have these massive teams of people who are doing investigation of things that have been flagged as fraudulent, but they're not. And so it's a waste of resources that you've got these investigators trying to manually determine whether there was actually fraud. And it's not a great customer experience, right? So for people who have traveled to this country, how many people have had their credit cards stopped because they're, okay, right, so it's people, this is a rule that's in place, okay? Suddenly this person's in Berlin, you know, like, that doesn't make any sense, you know? And, but maybe if they knew that you, I don't know, so there's sometimes the rules throw off these false positives, and that's annoying for customers. If it happened often enough, you might say, geez, you know, maybe I should be switching a bank, or like, why can't I use, you know, this is my only credit card I have with me, like I got to use this thing. So that's a problem also for customer satisfaction, not simply on the operational side of having to chase down these instances flagged for fraud. And then there's also just direct fraud loss. Of course, you want to avoid that. That's related to the to both of those true positive and false positive rates. And one thing that's also happening is that, you know, while all of the all of the tools and kind of agile processes and availability of information and of deep learning and machine learning tools, fraudsters also have access to those. There's a whole other dark side of the web and marketplaces that are taking stolen identities, stolen credit cards, and are making those very readily available to people who are willing to go looking for them. And there's this fast evolution in the black market means that there's even greater pressure on financial services companies to have a solution that will enable them to iterate quickly. So when new fraud techniques come up, that you can respond quickly to those. And so what we find is really essential in order to respond to those changes quickly, is that to begin with, we need to be keeping track of how well our existing models, whether they're based in traditional machine learning models and XGBoost, or whether they're a rules engine that has some of these, like, okay, more than 1,000 miles, you know, from the last transaction has, you know, there's more than 1,000 geographic miles between the last transaction and the current one. That you have a set of rules, whatever it is, that you want to know how well are those performing on the data that you have, and you want a framework basically for incorporating potential new models and managing those. So an analytic ops environment benefits, and you know, it requires a model management framework. So you can look at the many models that you're running in production at the same time, see what their performance characteristics are, see whether they're still doing as well as when they first went into production, see whether they need refreshing or not. And there also needs to be an integration of more modern techniques with some of the legacy systems. And this is something that is particular to retail banking, but oftentimes, you know, in a lot of settings, whatever the production system is, like, there are a lot of there's a great kind of built-in resilience to that system. It's very robust. It's been battle tested. So we don't want to replace a rules engine that's used to detect or to stop transactions, but we would like to make it much better. And so a model management framework helps us to do that. Once you've got these different ideas, you're using AI to come up with a new. It requires some data processing beforehand. Those pre-processing steps we want a framework that will enable on an ongoing basis data that's streaming in to be fed into kind of ETL and pre-processing pipelines to prep things for production models. So we have an ingestion pipeline there, and then we also need a place where the data scientists have an interface to this ops system, so they can potentially check out models. They can check in candidate models into this kind of champion challenger model management framework, and then also having some tooling to enable links between the models that people develop and these different investigators. In this case, in the fraud scheme. And that for us, Teradata, of course, we have plenty of proprietary technologies. Most notably our data warehouse, but we work very extensively in the open source ecosystem. We've made many contributions to that ecosystem, and we also certainly benefit very much from that. We, for example, for model management, we've built on top of Git for version control, but of course for analytics, one needs more than just the kind of the version control capabilities of Git. You need some more metadata and some things more about the models and the data. So we've come up with things around there. And we're also cross-engine in terms of the kind of models that we support. So we have plenty of data scientists, and plenty of our customer data science teams will be using Spark, or they'll be using TensorFlow, or they're using R or Python, and we're very agnostic about those tools. What we want is business value, and how we get there is up to you, and maybe in partnership with us. So, and advanced analytics platform, of course, needs to fit into a broader data infrastructure and application infrastructure. So we have a lot of APIs and connections to the customer systems in order to make sure whatever it is that we're finding, right, isn't making it into production. And that's why, at least at this point, we talk in terms of our accelerators. But like most of our customers require kind of custom development work in order to integrate these new capabilities into their existing processes. And the results have been very strong for us. We've looked at a lot of different types of like deep learning models, but as well as ensemble, traditional machine learning models, and customers are seeing more than 30% increases in detection, so true positives, and 44% reduction in false positives, and seeing millions and millions of euros in operational cost reductions on a monthly basis. There's lots of great strength here. So the red dot is the pre-existing rules engine, and some of these. So the green line was a ResNet deep learning model, and we've got a number of other deep learning models. The blue one is a logistic regression and gradient boosted trees approach, an ensemble of those two models, and we see them performing better at various false positive rates along the x-axis. We've also so part of the system, right, is to make it easier to know when things are going well or when things are going wrong, and also keeping track of kind of compliance. One of the things in the banking sector is a requirement for kind of interpretability of the model, and this has been one of the things that traditionally has been a challenge for highly nonlinear models like deep learning models. But we also are implementing some of the more cutting-edge techniques for enabling model interpretability, like locally interpretable model agnostic explanations, or the LIME framework, which is compliant also with GDPR, so the EU's new General Data Protection Regulations. So a lot of this work we've done with Danske Bank. And we also have other major customers in the US and elsewhere in the world. But this is some of these numbers came from our customer Danske Bank. And by putting in this analytic ops framework, we were able to foster deep learning adoption by the data science team there, and to improve data quality for all of their both traditional and deep learning models with kind of improved data ingestion processes. These analytic ops capabilities then also support not only business units, but they also support other kind of traditional machine learning practitioners, because a lot of that functionality around model management, or like, it could be that XGBoost is the better way to go, or at least until you've gotten to a deep learning model that's actually outperforming it. So let's just go with what works, and because we're agnostic about the different engines that you might run, we can better leverage the innovations that might from wherever they might come. So I've spoken a bit about the Analytics Ops Accelerator, and this is this is an end-to-end framework that's facilitating the training, deployment, and management of both traditional and deep learning models at scale. We oftentimes will use Teradata data. We have a Teradata ecosystem product called the Analytics platform that does have some optimizations for running analytic ops, but it's something that we also have customers doing on Hortonworks plus AWS, and for some of the model training and that. So this is very much a framework and a set of IP and solutions rather than a particular product. We also aim to enhance model training, so making it easier to come up with a model that's making it easier to train your models, and then also to make adjustments to those models so that they perform better. We do have some interface elements that are built in kind of a modular format, so they can integrate with whatever tools you may be using within your data science team. This is another, so we automate the production and deployment of models that can happen on wherever your infrastructure is. And we want to support, we have a challenger model management, making it easier to identify the winning model and then to also push that to production with a very simple mechanism. And by having this kind of unified model management framework, we facilitate collaboration around analytic assets. Collaboration and also competition. Well, different teams will collaborate with one another. I mean, so yeah, have you tried this model? We found that this worked in fraud, but also in other settings as well. In fraud, you'll have a lot of silos of data and also silos of employees who are working on particular types of fraud in any large enterprise client. And so they're going to have different practices. They might have different tools. And it used to be that there wasn't any way of kind of exchanging data or exchanging ideas and exchanging innovation in a really kind of consistent way. But now we have a technique for making it much easier to collaborate, having a common kind of a common baseline understanding of how well a model is doing, and ways of sharing that and building on it with each other. Okay, and with that, I'm very happy to take questions, and appreciate your attention. And for those of you who are jet lagged from abroad, especially, I know it's difficult. So thank you very much for that, and let's chat. Yes. Yeah. Yeah. So okay. So the question was, you mentioned that here. Why don't you just repeat it? See if we have this thing on.
Hi, I'm Khaled Tochi, an engineer from ING.
Great.
You've mentioned that you're a data scientist, push their code into a Git repository, and it will be somehow automatically deployed into across the DTSP.
Yes. Yeah.
And you said that you have a framework which allows the data scientists to monitor and manage their code that they've checked in. Can you elaborate on that? How does that system look like?
Yeah. So it's a combination of. I mean, so we developed a Jupyter plugin. So Jupyter is a very common notebook interface that data scientists use for developing their code, and so they'll make some changes there, and then we have a plugin there for pushing that to Git. There's also an interface for just looking at some basic diffs there. I mean, you could go to Git for looking at more history and more information, but some looking at the diffs between the model and some other one. And then we're using there's a process for using Jenkins to automate the build that goes into production. Yes. Yeah. So the main tool for doing the model management would be via Jupyter plugins. Right.
You mentioned that you're using Lime to explain the results of your neural networks. You also wrote that it makes it compliant with regards to GDPR, and I wonder
That's my understanding.
And how does it make it compliant?
How does it make it compliant? My understanding is that from that customer engagement that they were that Lime was adequate for GDPR. Do you have special expertise to speak to that?
Yeah, I'm just wondering, because GDPR covers a lot around data privacy and compliance, and because Lime just explains which data is being used and in the neural networks and which features are the most important, it still does not.
Right. So maybe this is a banking regulation. That I appreciate your that it is. That it's so there oftentimes are banking regulations regarding what the models or the different detection models that you're running, in terms of what you can use and what you can't, and if it's too black box, then it's non-compliant. So this was shedding some light into the black box. Is that yeah, I mean, using Lime is not, it doesn't mean that you've gone down the checklist of GDPR for all the other aspects of data privacy and that. But I think with regard to kind of like, can you justify that you flag this transaction as fraudulent? What are you using for that this was considered to be useful? So thank you for the question. I think somebody next to you had another question.
Last year, I heard Nadeem Gulzar from Danske Bank explaining about that journey as well.
Could you hold it closer so we can all hear it?
Last year, I heard Nadeem Gulzar from Danske Bank
explaining
about that journey.
Yes.
And
what do you have to say?
He also there mentioned that they had high percentage improvements in terms of their detection rate in fraud.
Great.
So the 30 to 40% you mentioned today, is that compared to last year? So it's building on the improvements that they had experienced also last year, or is it like going further back?
That's a great question. Yeah. So do you know actually?
Yes, sir. Yeah.
Frank? Is
Frank
another
Teradata
colleague?
and I will mention that tomorrow as well in my presentation. I think the improvement is now even a little higher. So the last numbers I heard was 50% improvement in the prediction of fraud, and 60% decrease in the false positives. So, yeah.
And can that be related alone to applying a deep learning framework on top of the machine learning they talked about last year?
Mainly, yes. Mainly is really they where you saw in Nick's chart that already by using traditional machine learning models they could improve from their starting point, their rules engine, right? But that additional improvement was just possible by using deep learning. And interestingly, deep learning on a not traditional deep learning data set, because they're mainly banking transactions, and we had kind of we had a step in between. How can we take a picture, transform banking transactions into a picture somehow, and I think that's where the real value lies. It's not just the deep learning itself; it's preparing the data for the algorithm as well, and coming up with the best deep learning methodology as well.
So this is a really great question. I mean, I love the idea. So yeah, you had that figure was how much better you did than the rules engine, at some point in the past, and and will you continue to get that? Because the promise of having the analytic ops framework is that you can continue to get that. So why would you get that? Well, why would you get it? Well, one is because it's easy to replace existing models with better performing models. Then the question is, well, where do those better performing models come from? And they can come from data scientists, via kind of manual exploration or coded exploration of the parameter space, or using new models that are either traditional or deep learning or some combination of those. Or they can also come from something that's more automated, right? It could be that the refresh and innovation of detection could also itself be automated. And we do have projects around the automated exploration of hyperparameter space and of existing models. So you can have these two sources and a common framework for both comparing those and recognizing advances, so that you can continually find that frontier and continually move up that detection percentage. Looks like we have a question down here.
Thank you. Could you summarize maybe how this product or set of products compare with open source solutions like Seldon Core or Pipeline AI, at least on the analytical ops? And how long has this been developed? For how many years?
Got it. So what were the two?
Seldon Core.
Seldon Core and the
Pipeline AI.
And Pipeline AI. Yeah. So it's been in development for in the process of kind of like field engagements, right? So this has been like a field developed set of I wouldn't call it yet. I mean, a product, right? So this is these are pieces of code that are reused, that have been useful. I mean, they're definitely solving some challenges that we've had across a number of customer engagements. I'd have to get back to you in terms of like a kind of a point or feature by feature comparison with Pipeline AI, which I know is a player in this space as well. Yes, I'm sorry I can't answer the question directly right now. Okay. If there's no more questions, you're welcome to come up here afterwards. But hope you have a great conference, and do stop by at Teradata booth as well.